The relay interlockings are laid out geographically using plug-in sets which are factory wired, tested and sealed before delivery. The rack plug boards are resiliently mounted to line up with the set contacts. The holes above the contact blocks receive interlocking pins. This ensures only the correct unit type can be plugged in. Each interlocking is provided with a test unit. Relays to British Railway Specification 930 series are plugged into the sets. A further non-interchange arrangement ensures only the correct relay type is plugged in. When all the relays have been plugged in, power is switched on, and testing commences. You see in progress the testing of route locking. This is done by simulating train movements from a test panel and ensuring that points remain locked until after the passage of trains. The route under test is denoted by a line of white lights, and the position of the train is seen as the white lights change to red. A third member of the testing team records each test as it is made. Testing is not only confined to the signal box.
Signal AWOL to signal Baker. Signal D42 displaying 1 red. Displaying 1 yellow. Displaying 2 yellows. Displaying 1 green. Over.
Route setting is done by the NX entrance-exit method. To set a route, the entrance button is pushed until it flashes. The exit button is then pushed, white route set lights appear, and the entrance button light becomes steady. When all points are in the correct position, the line of white lights is continuous and the signal clears. White lights also denote the extent of overlap. You see here a normal overlap. Sometimes a full overlap is not available. A second exit button is then used to set a reduced overlap. The clearance of the signal is then delayed to check the train. In the case shown, after a route is set into the sidings, a reduced overlap is set into the platform. A feature of the system is that although a delayed clearance route has been set, the setting of the route ahead will cancel the delay of the first signal as shown. You see this again in close-up. Overlaps may be swung automatically if there is a free overlap available when a conflicting route is set. In this simple case, the overlap for the down route is lying into the sidings. Calling the route from the up platform automatically swings the overlap out of the way. In this more complex situation, there is an overlap for the down route set round the spur, and an overlap for an up route into the spur extending foul of the up main. Calling a route up the main will now swing both the other overlaps into alternative positions, allowing the up main route to clear. When a route has been set, it will only release after the passage of a train. If the entrance button is pulled before this has occurred, the route is held for 2 minutes. During this period, the signal indication flashes. Overriding controls can be used if there is a remote control failure. A 3-position switch is provided, which in the auto position allows through running to take place. In the signals on position, all signals are returned to danger. This is how it operates at Gravesend. When the signals are returned to danger, all routes are held for 2 minutes. A systems indicator is provided in the relay room for each interlocking. This shows the state of the interlocking during route setting to assist fault finding. After a route has been called, the next route cannot set until the green light reappears. A counter is provided to record routes set for each interlocking. During a typical rush hour, 220 routes are set in Dartford relay room, and the total for the first 3 months was 200,000. The train describer is of the 4-digit type with a display for each signal. A description can be set up manually by the signalman and interposed for display at any signal. The description will thereafter follow the movement of the train. Now we will see this again. The strobe effect seen on these displays is not visible to the operators. Areas with points and controlled signals remote from Dartford, such as Plumstead, Northfleet, Gravesend and Sidcup, shown here, are controlled from a local interlocking housed in a small relay room operated over a microcore cable link. The interlocking itself is standard geographical as installed at Dartford. The relays at each of the microcore cable links are miniature post office type. Each relay is connected to one line of the microcore cable and its common return wire. The cable consists of 238 cores of 0.0148 inches, that is about 15 thou diameter, copper wire, with a flexible center core of a 1/4 inch diameter. It's provided with an aluminium tape moisture barrier and a brass tape for rodent protection. This type of remote control is only economic for distances of up to 7 miles. Microcore cable can only be manufactured in nominal 500-yard lengths, and as 31 miles of this cable are required for the scheme, 107 joints such as this are required.